Okay, 11.1 equations with variables on both sides. So, example number 1. Andy's rental car charges an initial fee of $20. So we know that we're going to have an initial fee of $20 plus an additional $30 per day. So we're going to have a constant and a variable on both sides. So if we look at Andy's side of the equation first, Andy is going to have $30 per day. That's the constant rate of change. So the way that we write that is 30x. The constant rate of change is $30 per day. 30 is the coefficient, x is the variable, plus an initial fee of $20. That's Andy. Now we go to the next sentence. Buddy's car rental charges an initial fee of $36. So now we're going to have the other side of the equation. It's going to have Buddy. And Buddy is going to have 36 plus an additional $28 per day. The constant rate of change is the 28 per day. And then we're going to have the initial fee of 36. Okay, that is how we set up this equation, because we want to figure out the number of days that they're charged the same. So we want to know, when does these two expressions equal each other? So when we have variables on both sides and constants on both sides, we want to get the variables to one side and then the constants to the other. And it doesn't matter which side we choose for the variable and which side we choose for the constant. We typically want to have the variable be the positive higher number. So we're looking at 30x here and 28x. This is the positive higher one. So we're going to put the variables on this side of the equation and the constants on this side. So to get the variables all to one side, we're going to get rid of 28x. We're going to do the inverse, or the opposite, to both sides. Remember, with equations, what you do to one side, you have to do to the other side. So this is going to cancel out. We're going to be left with 36 on the right side. Bring down the equals. Bring down the 20. And then 30x minus 28x is 2x. Okay, bring down the plus sign. Now we got to get the constants to one side. So we got to get rid of plus 20. The inverse, or the opposite of plus 20, is minus 20. What you do to one side of the equation, you have to do to the other side. We bring down the 2x. This cancels out. 36 minus 20 is going to get me 16. Now the 2 and the x are multiplying. The inverse of multiplication is division. We're going to divide both sides by 2. So this is going to cancel out and make 1x. But in algebra, you don't write 1x, you write x. 16 divided by 2 is 8. So it's going to take 8 days before both Andy and Buddy are charged the same. Okay, let's go to the second example. Okay, on the second example, it says a water tank holds 256 gallons. That's the initial fee. Okay, and then so we have the water tank, let's just call it tank 1. And it's going to be 256. But it's leaking at a rate of 3 gallons per week. Unfortunately, the vocabulary word leaking is a negative thing. So what's going to happen is this is a minus 3x. So that's for tank 1. A second tank holds 384 gallons. That's the initial value of the tank. But it's also leaking at a rate of 5 gallons per week. So once again, we have a negative vocabulary word, so we're going to be doing minus 5x. This is a constant rate of change, 5 gallons per week, 3 gallons per week. Those represent our variables. Okay, so now we want to get the variables to one side and we want to get the constants to one side. This is a minus 3x and this is a minus 5x. Remember, I want to put the variables to one side, but I want it to be a positive value. So in order to do that, I could get rid of the minus 5x here by doing the inverse, which is plus 5x. Once I do that, that will get me a positive variable. Because this cancels out, a minus 3x and a plus 5x is a 2x. So now we're going to say 256 plus 2x equals 384. Now I have to get rid of the constant 256, so the opposite of 256 is minus 256. And we're going to subtract 256 from both sides. So we're going to borrow. 14 minus 6 will get me 8. 7 minus 5 is 2. And 128. Bring down the 2x. The 2x are multiplying. The inverse is division. If you do it to one side, you have to do it to the other side. So this becomes 1x, or x. 128 divided by 2. It's going to go in there 6 times. It's going to go in there 4 times. So we have 64. Okay, let's flip it to the back side. Oh, and if we're going to label this, we have, this is actually, one of these going to be the same. In about 64 weeks will they be the same. Alright. Okay, example 2. Write a real-world situation that could be modeled by the equation 150 plus 25x. Well, the left side is where we have a constant of 150 and we have a constant rate of change, the 25x. That's the variable. Where the right side of it is a constant rate of change of 55x. So an example could be a handyman charges $150. That's the initial fee plus $25 per hour. That's the constant rate of change. That's for the first handyman one. So this represents the handyman. Okay, and then you have how many hours would a job have to take for a handyman's fee of a painter to be the same. So we have the $55 per hour. That's the painter. Alright, we want to write a real-world situation that could be modeled by the equation 30x equals 48 plus 22x. So let's maybe talk about a tennis club or some type of club. And so we have a tennis club. A tennis club charges $30 per session to play tennis? Okay, so that's the left-hand side. The constant rate of change is $30 per session. Now let's say we have another club, so another tennis club. Charges an annual fee of $48 and $22 per session. Okay, so the second tennis club charges an annual fee, the flat fee of $48 plus $22 per session. So we want to know after how many sessions is the cost the same at the two clubs? Now this is just one example. There are multiple ways that you could write this.